Hello, and welcome back to my YouTube channel. My name is Professor Govala, and today I'm going to be talking to you about parallel combinations of inductors, and I'm going to be proving that to you of how we get an equivalent inductance. So what I'm going to first do is I'm going to say that this is what I consider case 1, and this is what I consider case 2. I know that the current entering here has to equal the currents leaving, right? Because it's entering a node, right? So the current entering the node has to equal the current leaving the node. And I also know that since the inductors are in parallel, the voltage drops across L1, L2, and L3 have to all be the same. So let me call this plus minus V1, plus minus V2, and plus minus V3. Okay. And last thing I want to label here is that this is what I call my equivalent circuit. Okay. So in terms of writing equations, we're going to start off with case 1. And I'm going to say that Vs is equals to V1, which is equals to V2, which is equals to V3. And V1 is my inductor L1 di1 over dt, which is equals to V2, which is L2 di2 over dt. And this is also equals to L3, the change in current I3 over dt, or the change in time. If you don't understand where this equations are coming from, please check out my in-depth inductor video, which is in this current playlist, for an in-depth explanation of how we come about with this equations for voltage across an inductor. Okay, so let me call this set of equations A, and I'm going to write or say that I can write another set of equations using these sets of equations, and I can say then that di1 over dt is equals to Vs over L1. Additionally, I can say then that di2 over dt is equals to Vs over L2, and di3 over dt is equals to Vs over L3. All I'm doing is, for example, in this case, I'm just dividing this over here and solving for di1 over dt. So I hope that makes sense. And let me call this my sets of equation B. Okay. So another thing I want to write is my equations for my current, right? So I can say then that Is is equals to, or the current entering this node, right here, is equals to I1 plus I2 plus I3. Let me call this equation 1. If I take the derivative of Is over dt, this is simply d over dt, and Is is I1 plus I2 plus I3. Let me call this equation 2. And last but not least, I can write dis over dt as di1 over dt plus di2 over dt plus di3 over dt. And I can call that equation 3. Okay, so given all these equations, I want to achieve equivalency, right? So to achieve equivalency, in my case, let me use a different pen. In my case number 2, I could say then that Vs is equals to L equivalent dis over dt. I'm just talking about the voltage drop across this equivalence inductor. All right. So now what can I say? I can say then that if this is equation 3, to achieve equivalencies between these two circuits, we know then that, let me write it down here, get some room. We know then that we need to equivalate, let me do this as 4. We need to equivalate equation 3 and 4. All right. So then we can say then that L equivalent dis over dt must equal or actually a mistake was made here. What I meant to say was that using from this to achieve equivalency, I can say then Vs is equals to L equivalent dis over dt. But we know that to achieve equivalency, Is, right, or dis has to equal this. Okay. So then we can say then that this is equals to L equivalent di1 over dt plus di2 over dt plus di3 over dt. All right. And then this is equals to, we know di1 over dt is simply right here. So this is L equivalent Vs over L1 plus Vs over L2 plus Vs over L3. This is equals to Vs. I can go ahead and pull out a Vs from my equation. So Vs is equals to Vs L equivalent 1 over L1 plus 1 over L2 plus 1 over L3. Okay, the Vs's cancel out. So then this just becomes, this is just equated to 1. So then if I divide this by L equivalent and divide this by L equivalent, I'm left with what? I'm left with 1 over L equivalent is equals to 1 over L1 plus 1 over L2 plus 1 over L3. And L equivalent is equals to 1 over L1 plus 1 over L2 plus 1 over L3 inverse. And that is my equations for my equivalent inductance in parallel. So what I'm going to do now is I'm going to just write a general equation. So the general equation for inductors in parallel is L equivalent is equals to 1 over L1 plus 1 over L2 plus dot 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 plus 1 over Ln inverse. Or we could say then that this is I is equals to 1 over N 1 over Li inverse. So that's your general equation. I hope this makes sense. If you think it did and you liked the video, please give it a thumbs up. If you found anything here confusing, please leave a comment down in the comment section below, and I'll be sure to get back to you. And also, please share the video and subscribe to my YouTube channel. Thank you.